Hey guys, I'm going to go over 5 combining like terms problems. I'd say they're probably basic to slightly below intermediate level for Algebra 1, and I'll talk about some common errors that might come up. Let's take a look. So, let's start with this expression. If you look here, I've got 6 terms. Terms are separated by plus and minus signs. 4x, 3y, 2, 5x, y, and 7. Now, I'm going to basically use commutativity to move these like terms next to each other. I've got 3 sets of like terms. I've got my terms with x's, terms with y's, and just numbers. We call those constants. Once we reorder them, we can use associativity to simplify the expressions or part of the expressions in any order that we want. Honestly, guys, property names, they don't mean anything to me. It's how you use it. It's where you're trying to get. And we're trying to simplify this expression. And what that essentially is doing it is organizing it into a more, concise expression. When we do that, we make it more organized. So let's move some things around. Now, there's some people who might make some sort of symbol, like maybe a square around all the x terms, maybe an underline under the y terms. But I'm going to move them next to each other because I can. So I have 4x plus 5x. Notice here, I just shifted the 5x over here. That's usually through a number of steps, but we can do it in one shot. Y's as well. So plus 3y minus y. Notice I kept that minus sign or negative 1y. And I've said this in previous videos before. There's an imaginary 1 in front of that y. But I keep the negative sign. If you have a negative sign to the left of a term, it stays with it no matter what. Okay? And look at here. I'm going to do the same thing with that minus 2. And I have the plus 7, which is at the end. Now it makes it a little easier to understand. Now I can put like terms together, okay? I can put those together, these together, and finally those together. So if I'm adding like terms together, they're both an x, I simply add the coefficients. My coefficients, just a fancy name for the number in front of the term. 4 plus 5 is 9. I now have 9x. Here, I've got y terms. I have 3 minus 1, so that's important here. You could put plus negative 1. Minus 1 and plus negative 1 are the same thing. If that's easier for you at the beginning stage to move the terms around to make that a plus negative 1y, you can do that. We're not doing that here, but you could if you chose to. So I'm going to make this a 2y because if I do 3 minus 1, I have a positive 2. That's going to stay plus 2y. Finally, I have negative 2 plus 7. Okay? So we're adding a negative 2 to a 7. That's basically saying 7 minus 2, okay? We could even shift these around. We could say 7 minus 2. I could switch the order, as long as that minus sign stays with the 2. Negative 2 plus 7 is going to be 5. Again, a positive 5. We've simplified this expression as much as it's going to go. All right, so looking here, we have a parentheses, okay? We have an expression inside of it. Now, rule of thumb, if we're simplifying an expression with variables, an algebraic expression, take care of the parentheses first. And what I mean by take care of it, we're going to distribute. I'll backtrack with a video at some point and talk a little bit more about distributive property. But just to make it understandable now, I like to put little arcs here to signify that when you have a number outside of the parentheses, you are multiplying both of the terms inside of the parentheses by that number. Again, there's 2 terms here because there's a plus sign, and that's what separates the 2 terms. If it was a minus, it would be the same thing. We'd still have those 2 terms. So essentially, I'm doing 3 times x, and I'm adding it to 3 times 4. I'm showing you the intermediary step here. So let's write the rest of it, and then we'll resolve these. 3 times x we can symbolize with 3x. 3 times 4 we can simplify to 12 plus 2x minus 5. Now that we've taken care of that, it's a lot like the first one, except we only have 2 sets of like terms. So let me do some rearrangement. 3x and 2x are going to go next to each other. I'm going to put the plus 12 here, and I'll put the minus 5 here. Again, a key thing, make sure that minus sign stays with the 5. Now we can add like terms. 3 plus 2 is 5. We attach our x. We have 12 minus 5 here. That's a positive 7. So we end up with plus 7. This is our simplified expression for this one. All right, this one's a lot similar to the last one. The only difference here is we have a negative number that we're going to distribute. So let me go through that pattern again of creating the arcs. This helps me keep track of distribution. If I had more terms than just these 2 terms, it would help me remember that I have to multiply the negative 2 by each of the terms inside the parentheses. Okay? So we're doing negative 2 times 3x. Okay, and this is important here. These are 2 negative signs. When we multiply those together, we're going to get a positive, okay? For now, we can just keep it like this, just to show what we're multiplying, okay? But keep that in mind. Everything else is written as is. So negative 2 times 3 is negative 6x. The negative 2 times the negative 4 is going to be a positive 8. And then we're going to write the rest. Let's do our rearrangement. Okay, let's get those x's next to each other. Boom. Let's simplify these. Okay, so what's happening here? We're doing negative 6 plus 5. If you want to visualize it in a different way, it's 5 minus 6. We're going to end up with a negative number here. And I'm going to give it a coefficient for now, but we're going to get rid of it at the end for the simplified version. But let's just put it there for now. Again, this is negative 6 plus 5 is negative 1. And I have 2 positives here that I'm adding. 8 plus 1 is 9. Now, you could leave it like this, but most math teachers are going to look at it cross-eyed. They're not going to like it too much. You can get rid of that coefficient, but you have to keep the negative symbol. Okay, otherwise, we're changing its polarity, okay, the term's polarity. This is our simplified version. Okay, we have another distribution expression here. So let's take a look. We have 2 variables here, 2 different ones in the expression. We have x and y, x and y. We have a constant here. Again, attack the parentheses first to distribute. That should be the #1 play whenever you're simplifying an expression, if there is a parentheses. If you can simplify inside the parentheses, do so. Okay? We can't add those together. They're 2 different terms. So we start by distributing. We get 2 times x plus 2 times y plus 3x minus 4y plus 5. When you get better at this, you don't really have to put that time sign in between, but it's a nice middle ground step while you're getting used to getting this process down. Okay, let's rearrange. 2x plus 3x. 2y minus 4y. Keep that negative with the 4. And we add 5. 2x plus 3x is going to be 5x. Now we have 2 minus 4. That's going to be a negative number, okay? So 2 minus 4 is going to be a negative 2, and we'll attach the y onto it. And then we can add 5. That's our simplified expression. A note, is this the best way to write it? Okay, officially you could write these terms in any order, okay? As long as they contain the correct symbols, all right? This expression here is equivalent to the one above it. I could even take the minus 2y and put it to the end. However, it's good practice to keep the terms or the letters of the terms in alphabetical order and put your constants at the end, your regular numbers. It all depends upon your teacher, but most platforms online, most textbooks, they answer it in this type of order. So this would be the better version of your simplified expression. Okay, for this one, I changed it up slightly. I put a term in front of where we are going to be distributing, okay? It doesn't change anything, all right? If I see parentheses, I'm distributing first. That's my first goal every time. Then we can deal with combining like terms. While I'm doing this, I'm going to put the 1 in front. I'm not going to wait, okay? Again, if you have no number in front of a variable or even a combination of variables, okay, I don't want to sidetrack too much, but like say I had a term. You could have a term like this, x, y, z. If there's no number in front, I have 1 x, y, z. We'll get to that in a later video, but just keep that in mind. I have one of these plus, and at this point, guys, I'm just going to multiply these. Hopefully you have a little bit of practice. On your own, you should continue putting the multiplication symbol between them and writing it step by step. But I'm going to say 4 times x is just 4x. And I'm going to say, again, this is a positive 4 times a negative 2. We're going to have minus 8, okay, or a minus 2. Keep that in mind. It's a positive times a negative. And then I'm going to write everything else as is. I'm going to add a 1 here too, okay? So there's no variable in front of that minus x, so I'm going to make it minus 1x. Let's shift some things around, okay? Let's put our x's first. 4x minus 1x, okay? Keeping that symbol with it, that minus sign. I have 3y plus 1y. Again, you could put those in either order. You could put 1y plus 3y. It doesn't matter as long as those y's are together, just to help you out. Minus 8 plus 10. So I've reordered everything correctly here. Now let's combine. 4x minus 1x, we got 3x. I've got 3y plus 1y. We're looking at 4y. And finally, I have negative 8 or minus 8 plus 10. If you want to switch those around, you could have done that too at this step. You could have said 10 minus 8. Just realize you are doing a negative 8 here plus 10. Now, some people might even make that a plus negative 8. You can do that, okay? I'm just giving you some different ways to attack it, whatever visually helps you out. Negative 8 plus 10 is a positive 2. We end up with 2. Here's our final expression. If you'd like more algebra videos like this, please subscribe. Thanks for watching.